Okay, so let's do things together, like simultaneously. Get it? Like simultaneous equations. Okay, well, I'll have to keep trying and working on that. Anyway, so let's do simultaneous. And if we're given these two equations, y equals 4 of x plus 2 and y equals x minus 1, one good question is, what does it mean to solve simultaneously? Okay, and I mean, it could mean different things in different contexts. You might be like, you to find values for x and y to solve at the same time. I'm not sure. And in some cases, it could be that we're trying to solve when two graphs are equal to each other. So, or two functions. So here's a hyperbola. Maybe you can recall it from last year, but did we do many last year? I can't remember, but we'll get into them again this year. So this is like a hyperbola. Ooh, that looks like, like this and like this. And this thing here is a straight line. So what we're seeing is, when are these two things equal to each other? So we're looking for that point there and that point there. I'm not even drawing it on a set of axes, particularly to disguise the fact that I've drawn this so badly that they should kind of look something like that more, and there should be an asymptote. But the point is, they're two graphs, and we're asking when are they equal to each other. So we're going to get two sets of coordinates. Here we're going to get an xy, and here we're going to get another set of coordinates, an xy. So let's see how we can do that. Now, as I said, you could get given in a graph form, which is going to happen, or you might just get asked, solve simultaneously. Okay, well, in terms of the graphs, what I think is quite useful is that we ask ourselves, when is this graph, y equals 4 of x plus 2, equal to this graph? So in other words, what we're asking ourselves is, when are these two things equal to each other? So we could just put them equal to each other. 4 of x plus 2, we're asking ourselves, when is that equal to the other graph, y equals x minus 1? So when is that equal to x minus 1? Hey, look at that. We've gone from two equations and two variables, and now we've got one equation, one variable. So you can solve that equation there, right? Well, with a bit of luck you can, but even without, you shouldn't need too much luck. I mean, you're looking here, 4 over x, and you might have looked at this in one of two ways. You might have said, well, let's write this over a common denominator on each side. So 4 over x is 4 over x plus 2x over x, because this was 2 over 1, so 1 times x. And on this side, well, we had to multiply each of these by x to get that. And you might even have gone to the next step. 4 plus 2x equals x squared minus x. Okay, quadratic equation. We're going to solve, rearrange x squared. Wait a second. X squared, let me do it on this side, might make more sense. So we got x squared, let's subtract 2x on each side, so that, because what we want is 0 on this side, right? We've got x squared, subtracting minus x minus 3x. Okay, let's subtract this 4. So what we do on one side, we do on the other, right? Minus 4, hey, quadratic equals 0. Quadratic formula you might reach for. I reckon this is going to be solvable for, I mean, it's 2 and 2 or 4 and 1. And 4 and 1 seems to work. 4, 1, minus 4 plus 1. Remember, nothing wrong with using quadratic formula, but that's a bit quicker if it is useful to factorize. So x equals 4 or x equals minus 1. Pause, breathe. Right? And then we just substitute in. So if x is 4 or x is minus 1, which equation do you want to substitute that into? Equation 1 or 2 to find out what y is. I was going to say and y, but we used up the good jokes at the beginning. So I would go for equation 2. Look, it's a whole lot simpler, right? Look at this thing. It's like y equals x minus 1, not that other one there. It's like over x and that. So y equals x minus 1. So y equals x minus 1. So we can just sub each of these in to get our values of y. Y equals 4 minus 1 equals 3. So I think that this is a great way to finish it off, is to finish it off in coordinate form. 4, 3, 4, 3. Or y equals x minus 1. Y equals x minus 1. Y equals minus 2. Finish it off in coordinate form, because so often we're going to use this in our graph. So if you've got it in that coordinate form, there's no swapping around x's and y's. So there it is. Solve simultaneously. Done. I had another page. I thought it would take us more. Okay, and second example. Y plus 2x equals 2. Y squared plus 2x squared equals 3xy. Oof, this doesn't look like, well, this looks like a straight line. What's happening here? Is this, I don't know. Definitely not something we've come across just yet. So you're not going to be asked to draw that. And we're just going to do this algebraically. Now we can't just go, oh, that equals that, because on this side we've got y plus 2x. This we got y squared plus 2x squared. It's not like we've got y equals y equals. So let's work on that. So let's scrap that. Pause and get a breather so you can jot those ones down. And maybe, you know what ideas do you have at this stage? Okay, maybe your ideas are similar to what I'm going to try now. Maybe they're different and good strategies. I don't know. I'll see when I read them. But what sticks out to me as a way of doing this is to go, let's write this as y equals something. So let's subtract 2x from each side so that, you know, that's just 0. And therefore on this side we've got 2 minus 2x, or minus 2x plus 2. Now we can take this y, must be the same as this y here. So whenever we see a y in this equation, we're going to replace it with this way of writing y, because these two are equal. So we're going to see y squared plus 2x squared equals 3xy. So wherever we see a y here, we're going to write, here's another way of writing y, 2 minus 2x. Here's a y. Hey, another way of writing that is 2 minus 2x. Whoop. Okay, so not too bad. Like, rearrange y, put it in here. Now, for the sake of not making you stare at your screen for too long, how are you feeling on multiplying this bracket out, multiplying this into the bracket, solving for x, getting your two solutions? Once you've got your two solutions, substituting each of those back into this equation here will be much easier to get your two solutions of y, and just running through the rest of that. Just let me get an indication of how you're feeling. Solve this quadratic and go from there. Okay, well, that's that. I'm going to actually stop the video and I'm going to finish off writing this so you've got access to this on the website so you can look at this PDF and see me work through it. So, how's that sound? Well, when things changed, I rather just hit pause. You can see at this stage over here, you can factorize this and you could go, bracket, 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 bracket equals 0. But to be honest, at this stage, I can't see, is it 3? And it's not too bad, I guess, because you could see this is 1 and 2. But I'd be very tempted at this stage to use the formula. So I'm going to do that off on the side and the factorization here. I'll be back in a second. And another weird jump cut. And we're back. And what I notice here, just because we've just done nature of roots, is that this bit under the square root sign is 1 perfect square. So we know we're going to get rational roots. And we do get the same rational roots, 2 over 3 and a half. And then we'll sub that back in. So y equals 2 minus 2x. Y equals 2 minus 2x. So we've got y equals 2 minus 2 over 3. Or y equals 2 minus 2 a half. I guess into the calculator if you wanted, but 2 times a half is 1. 2 minus 1 is 1. Remember, nice to finish it off in coordinate form. Well, I think so at least. So this related to our half and 1. And on this one, y equals 2 times 2/3 is what? 4/3. So 1 1/3. So what? 2/3. Does that work out to be 2/3 as well? Yeah, I think it did. So when x is 2/3, y is 2/3. So effectively, there are two solutions. Well, there were two solutions. Have fun.